Our problem is that you're given a floor with a volume of 765 meters cubed of space for 4 rooms. Each of our rooms has to be a different by 20 meters cubed, and there are 2 pieces of furniture currently on the floor that take up 250 centimeters cubed each.
With this information given, the question is, what are the dimensions of each room?
The first step I'm going to do is convert my 250 centimeters into meters. So I know that in each meter there are 100 centimeters. So I'm going to divide 250 by 100 equals 2.5. So each piece of furniture is 2.5 meters cubed, but there are 2 pieces of furniture. So I'm going to say 2 pieces of furniture times 2.5 equals 5 meters cubed. So we're going to subtract 5 meters from the total number of space that we have for the room. So 765, take away 5 meters equals 760 meters cubed. This is the amount of space that we have left over to work with for the 4 rooms.
So to solve for solution 1, we decided to do a trial and error method. So we knew that we had a volume of 760 meters cubed. So we started by assigning room 1, this one here, with 100 meters cubed. From there, we knew that each room had to be at least 20 meters cubed difference. So we decided to assign room number 2 with 130 meters cubed. From there, we assigned room 3 250 meters cubed. And with that, we added all of the rooms together. So we added a volume for room 1, room 2, and room 3 to get the total amount of volume between the 3 rooms, which came out to 480 meters cubed. Now to find for room 4, we subtracted 760 meters cubed, which is our total amount of volume, and we subtracted 480. To find the volume for room 4, what we did was we took our total amount of volume, which is 760 meters cubed, and we subtracted our volume for rooms 1, 2, and 3, which is 480 meters cubed, to find the volume we needed for room 4, which was 280 meters cubed. So now to find the dimensions of each room, after we found the volume of each room, we have to find the length, the width, and the height of each room. So volume is equal to length times width times height. So we've used a trial and error method for each room to find the dimensions for it. So for the first room, we have a volume of 100 meters cubed, which would be equal to length times width times height, and we plugged in different numbers that we found to make 100. So the numbers we chose here were 2, 10, and 5, and when you multiply these all by each other, you find the length, the width, and the height for 100 meters cubed.
So the dimensions for room 1 are 2 times 10 times 5.
So for the rest of the rooms, we continued our trial and error method to find their dimensions. We plugged in different numbers for the length, width, and height in each of the rooms, and we came up with these numbers that worked for the meters squared. So our final room is 10 times 7 times 4 meters equals 280 meters cubed.
Therefore, the dimensions for each room are as follows. Room 1 is 2 by 10 by 5. Room 2 is 2 by 5 by 13. Room 3 is 10 by 5 by 5. And room 4 is 10 by 7 by 4.
Good. So for starting for solution 2, we took the information we already knew from the beginning, which we had our 765 meters cubed as our volume, and we subtracted the 5 meters cubed for our pieces of furniture, leaving us our volume of 760 meters cubed. So for solution 2, we decided to create a formula to help us to solve the problem. we said that R is equal to the room with the smallest volume. So we know that volume is equal to R, and because each room has to be 20 meters cubed difference, we said R plus 20 would be our next room, so it's 20 meters cubed difference. And then our next room, we add another 20 to that, so it would be R plus 40, and then our last room would be R plus 60.
So now I'm going to solve it. So volume we know is 760. For R, because there's 1, 2, 3, 4R, plus 20 plus 40 plus 60. So 760 equals R plus. I'm going to bring this to this side, so equals 4R. So I'm going to divide by 4.
Original equation, we can take these 4 rooms and label them as room 1, room 2, room 3, and room 4. From that, I'm going to take those and say R, which is room 1, is equal to R, which is equal to 160 meters cubed, which we found from our equation over there. Next, we can take room 2, which is equal to R plus 20, and we know that is 180 meters cubed. Our next is room 3, which is R plus 40. So for room 3, we know that our volume will be R plus 40, which will give us 200 meters cubed. And for room 4, we know that it's R plus 60, which will give us 220 meters cubed. As you can see here, there's a difference of 20 meters cubed between each of these rooms.
So similar to how we solved solution number 1, we were able to find the dimensions for each room. So room 1 was 160, so we found it that 2 times 10 times 8 would be the dimensions for that room. For room 2, that is 180 meters cubed, we found 2 times 9 times 10. Room 3, we found was 200 meters cubed, so we found 2 times 10 times 10. Finally, room 4, which was 220 meters cubed, we found that the dimensions would be 2 times 11 times 10.